Before Voyager ever left Earth, it was already dying. That was never a secret. No illusion of permanence. No fantasy of return. From the very first calculations, the engineers knew the truth. This machine would outlive its usefulness long before it reached its destination. Its energy would fade. Its instruments would go blind. Its voice would thin into silence. And yet, they launched it anyway. That decision hides a strange question we rarely stop to ask. Why create something you already know will end? Voyager was born inside a narrow window of time. A rare alignment of planets, Jupiter, Saturn, Uranus, Neptune, positioned in a way that happens once every 176 years. Miss that window, and the opportunity vanishes for lifetimes. There was no room for hesitation. No space for perfection. So humanity chose limitation. Voyager's power source was a block of plutonium-238, decaying atom by atom, generating heat that converted into electricity. At launch, it produced 470 watts. Enough to run everything. But decay is patient. By 2025, that number had dropped to 249 watts. 3 light bulbs. That's all that stands between voice and silence. Every year, less power. Every decision, which instrument dies next. This wasn't failure. This was design. Voyager was not built to last forever. It was built to go as far as possible before the silence caught up. And still, one decision stands out above all others. If the mission had an expiration date, if silence was guaranteed, why attach a message meant to survive beyond that limit? Why speak when no answer was expected? In 1965, a Caltech graduate student named Gary Flandreau was calculating planetary trajectories when he noticed something. The outer planets were aligning. Not perfectly. Not dramatically. Just efficiently. If you launched a spacecraft at the right moment, you could use Jupiter's gravity to fling it toward Saturn. Then use Saturn to reach Uranus. Then Uranus to Neptune. Each encounter would add velocity, thousands of kilometers per hour, without burning a single drop of fuel. It was called the Grand Tour. And it would only work in a 4-year window starting in 1977. Miss it, and the next chance wouldn't come until 2153. NASA had a choice: build one perfect probe, or 2 functional ones. They chose 2. Voyager 1 and Voyager 2. Identical twins. Each weighing 722 kilograms. Each carrying 11 scientific instruments. Each powered by 3 cylinders of plutonium-238 slowly burning themselves out. The mission was ambitious, but the math was unforgiving. Plutonium decays at a fixed rate. You can't slow it down. You can't recharge it. The mission clock started ticking the moment the RTGs were installed, months before launch. By the time Voyager 1 lifted off on September 5, 1977, it had already lost power. The mission was ambitious, but the math was unforgiving. Plutonium decays at a fixed rate. You can't slow it down. You can't recharge it. The mission clock started ticking the moment the RTGs were installed, months before launch. By the time Voyager 1 lifted off on September 5, 1977, it had already lost power. Engineers knew what this meant. Instruments would need to be shut down. Not because they broke, but because there wouldn't be enough energy to keep them alive. The mission had to choose its own ending, piece by piece. First the ultraviolet spectrometer. Then the infrared radiometer. Eventually, the cameras themselves. Voyager wasn't designed to explore indefinitely. It was designed to see as much as possible before going blind. And in that brief window, between launch and darkness, it saw things no human eye had ever witnessed. But seeing didn't bring understanding. It brought something else. On March 5, 1979, Voyager 1 passed within 278,000 kilometers of Jupiter. And for the first time, humanity saw Io up close. Volcanoes, 8 of them, erupting simultaneously, throwing plumes of sulfur 300 kilometers into space. The first active volcanism ever discovered beyond Earth. Europa was smooth. Too smooth. Almost no craters. Just a web of cracks cutting across ice. Something beneath that surface was erasing impacts. Something liquid. An ocean. Hidden under kilometers of frozen crust. Warmed by the same tidal forces tearing Io apart. Saturn's rings weren't smooth bands. They were braided, kinked, divided into thousands of individual ringlets. Tiny moons were sculpting gaps through gravitational resonance. At Saturn's north pole, a hexagon. A six-sided jet stream, wider than Earth, locked in place. Stable. Permanent. Rotating once every 10 hours. No one knew why it formed. No one knows why it stays. Titan had an atmosphere thicker than Earth's. Orange haze. Surface invisible. Weather. Seasons. A methane cycle analogous to Earth's water cycle. Rain. Lakes. Rivers. Just not made of water. Uranus was tipped on its side, rolling through space like a marble. Its magnetic field wobbled. 10 new moons no one knew existed. Neptune, violently blue. Winds at 2,100 kilometers per hour, the fastest in the solar system. The great dark spot, churning through an atmosphere that shouldn't have had enough energy to sustain it. Triton, geologically active despite being one of the coldest objects in the solar system. Nitrogen geysers erupting through ice. Surface temperature, minus 235 degrees Celsius. For a brief moment, it seemed like Voyager had conquered distance. Had unlocked the outer solar system. Had proven that human ingenuity could map the unknown. But then something became clear. Something uncomfortable. None of these worlds knew they were being observed. Io's volcanoes had been erupting for billions of years. In silence. Witnessed by no one. Europa's ocean existed whether we looked or not. Saturn's hexagon spun long before we noticed it, and will spin long after we're gone. Neptune's storms raged without audience. Voyager didn't conquer these worlds. It proved we were irrelevant to them. Every image sent back was a reminder, the universe doesn't care if we witness it. It doesn't pause for observation. It doesn't reward curiosity with meaning. Voyager saw wonders. But those wonders didn't need to be seen. And then, after the last planet, Voyager kept going. Into a region where even wonder becomes impossible. Where the only thing left to see is ourselves. On February 14, 1990, Voyager 1 was 6 billion kilometers from Earth. Far beyond Neptune. Far beyond anything it was designed to photograph. Carl Sagan asked NASA to turn the camera around. Not to see something new, but to see home. The request was controversial. The camera wasn't designed to point toward the sun. The risk of damage was real. The scientific value was zero. But Sagan insisted. So Voyager 1 rotated. Its camera lens swiveled back toward the inner solar system. And it took 60 images, a mosaic of the sun and the planets arranged around it. In one of those frames, Earth appeared. A single pixel. Pale blue. Suspended in a beam of scattered sunlight. No continents. No oceans. No borders. No cities. Just a dot. Carl Sagan later wrote, "Look again at that dot. That's here. That's home. That's us. On it everyone you love, everyone you know, Everyone you ever heard of, every human being who ever was, lived out their lives. Every hero and coward. Every creator and destroyer of civilization. Every saint and sinner in the history of our species lived there. On a mote of dust suspended in a sunbeam. The image didn't reveal new science. It revealed scale. Every war ever fought. Every empire ever built. Every belief ever defended. Contained in a fraction of a pixel. Voyager had shown us Jupiter's storms, Saturn's rings, Neptune's winds. But this single photograph, reminded us of something else. How small the stage is. How brief the performance. After the image was taken, Voyager turned its camera off. It never looked back again. And in that moment, something shifted. Voyager was no longer exploring. It was leaving. Attached to Voyager's side is an object that serves no engineering purpose. It doesn't generate power. It doesn't transmit data. It doesn't help with navigation. It's a 12-inch gold-plated copper disc. And it contains a message. Not for mission control. Not for scientists. Not even for humanity. For whoever finds it. The Golden Record was curated by a team led by Carl Sagan, and Drew Yen, and Timothy Ferris. They had weeks to decide what to include. What could represent Earth, not perfectly, but honestly. They chose sounds. The first sound on the record is a greeting from then UN Secretary-General Kurt Waldheim. Then greetings in 55 languages. Ancient and modern. Sumerian. Wu. Welsh. Hindi. English. Simple phrases. Hello from the children of planet Earth. Friends of space, how are you all? Have you eaten yet? We wish health to you now and forever. Then, natural sounds. Wind. Rain. Thunder. Surf breaking on a shore. Footsteps. Heartbeats. Laughter. A kiss. A mother and child. Then, music. Bach. Beethoven. Mozart. Stravinsky. But also Chuck Berry. Blind Willie Johnson. A Navajo chant. A Peruvian wedding song. Javanese gamelan. Bulgarian folk music. 90 minutes of humanity, encoded in analog grooves. There are also 116 images, encoded as audio signals. DNA structure. Human anatomy. Mathematical definitions. The sun. The planets. Continents. Oceans. A family. A classroom. A supermarket. Traffic. And instructions. The record's cover is engraved with diagrams showing how to play it. A stylus is included, a needle made of synthetic sapphire. The playback speed is indicated using the hydrogen spin-flip transition frequency as a universal reference. If anyone ever finds this, they're supposed to figure it out. The irony is impossible to ignore. Voyager will run out of power by the mid-2030s. Its transmitter will go silent. Its instruments will freeze. It will become inert, a piece of space debris drifting through the galaxy. But the Golden Record will remain. Intact. Playable. Unchanged. Long after Voyager stops being a machine, the record will still be a message. It was never meant for aliens we know are out there. It was a response to the pale blue dot. A refusal to let humanity pass through the cosmos without leaving evidence of its inner life. Not conquest. Not achievement. Just proof that we felt things. The Golden Record may outlive its creators by billions of years. A memory without a mind. A message without a reader. Drifting. For decades, Voyager kept moving. Past Neptune. Past Pluto. Past the Kuiper Belt. Into a region where the sun's influence begins to weaken. The heliosphere, a bubble of charged particles blown outward by the solar wind, extends far beyond the planets. But it doesn't go on forever. Eventually, it meets resistance. Interstellar space. The boundary between these two regions is called the heliopause. It's not a wall. It's not a line. It's a turbulent transition zone where solar wind collides with the interstellar medium, gas and dust drifting between the stars. Voyager 1 approached that boundary in 2012. Scientists watched the data carefully. Particle counts, magnetic field orientation, plasma density. On August 25, 2012, something changed. The solar wind particles dropped to nearly zero. Galactic cosmic rays, high-energy particles from outside the solar system, spiked. Voyager 1 had crossed. For the first time in history, a human-made object entered interstellar space. Voyager 2 followed on November 5, 2018, crossing at a different location, under different conditions, confirming that the heliopause isn't uniform. But nothing dramatic happened. No alarms. No visual marker. No sound. Just a quiet shift in the data. But nothing dramatic happened. No alarms. No visual marker. No sound. Just a quiet shift in the data. And yet, everything had changed. Crossing implies a line. A moment when you're on one side, then the other. But there wasn't one. Just a zone where definition stopped working. Where solar system became a question, not a fact. Engineers watched the data shift, but couldn't say exactly when Voyager stopped being ours. Was it the first particle? The 10th? The 1000th? The boundary exists. But only in hindsight. Voyager is no longer a probe of the solar system. It's an interstellar object. The Sun, from Voyager's perspective, is now just another star. Brighter than the rest, but not unique. Earth is invisible. The planets are invisible. Voyager is alone in a way no human artifact has ever been. And it's still moving. Currently traveling at 17 kilometers per second relative to the Sun. In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. In 300,000 years, it will reach the inner edge of the Oort cloud. It won't stop. Because there's nothing to stop it. No drag. No friction. No obstacles. Just motion. Inertia. Silence. Voyager is still transmitting. Not images. Not discoveries. Just telemetry. Temperature. Orientation. System status. The signal is extraordinarily weak. By the time it reaches Earth, Voyager's transmitter is outputting just 23 watts, less power than a refrigerator light bulb. And it's traveling across 24 billion kilometers. The signal spreads as it moves, diluting into near-nothingness. By the time it arrives, the power received by NASA's antennas is roughly 0.1 billionths of a billionth of a watt. To hear that whisper, NASA uses the Deep Space Network, 3 massive antenna arrays positioned around the globe: California, Spain, Australia. Each dish is 70 meters wide. Even then, it takes 22 hours for a signal to travel from Voyager to Earth. If engineers send a command, it takes 22 hours to arrive. If Voyager responds, it takes another 22 hours to confirm. A 44-hour conversation. And the conversation is ending. Every year, the RTGs produce less power. Every year, NASA has to make a choice, which instrument to shut down. 2007, Voyager turned off its plasma science instrument. 2008, the planetary radio astronomy experiment went silent. 2016, One of the thrusters was reactivated after 37 years to compensate for failing attitude control. Each shutdown buys time. But not much. Pausa longa, momento de tenseo maxima. Then, in 2023, something unexpected happened. Voyager 2 went quiet. For weeks, there was no usable data. No telemetry. No confirmation of its status. Engineers suspected a corrupted memory sector, a single bit flipped by cosmic radiation, triggering a cascade of errors. They sent blind commands, hoping Voyager would reset. Eventually, it did. The signal returned. But it was a reminder. One day, the signal will stop. Not because of a software glitch. Because there won't be enough power to send it. Current projections estimate that by 2036, Voyager will no longer have enough energy to operate its transmitter. At that point, there will be no final message. No goodbye. Just silence. One day, NASA will send a command. And Voyager won't answer. And no one will know if that silence began an hour ago, or a year ago. Communication, at this distance, isn't about information anymore. It's about confirmation. Proof that something we made still exists. Still moves. Still responds. And when that confirmation disappears, Voyager doesn't stop existing. It just stops being witnessed. After silence, time changes. Years stop mattering. Centuries become irrelevant. Voyager will drift through interstellar space for millions of years without alteration. No erosion. No decay. No memory. The RTGs will grow cold, but the spacecraft itself will remain structurally intact. Metal doesn't rust in the vacuum of space. There's no atmosphere to corrode it. No water to dissolve it. Voyager will look almost exactly as it does now, long after the civilization that built it is gone. In 40,000 years, Voyager 1 will pass near Gliese 445, a red dwarf star 17 light-years away. It won't stop. It won't slow down. It will simply pass by, silent, inert, unaware. In 296,000 years, it will reach the inner boundary of the Oort cloud, a vast shell of icy debris surrounding the solar system. It will take 30,000 years to cross it. By then, Earth will be unrecognizable. Continents will have shifted. Ice ages will have come and gone. Species will have risen and fallen. Human civilization, if it still exists, will have evolved into something unimaginable. And still, Voyager will be moving, carrying a golden record engraved with the words, "To the makers of music, all worlds, all times." At some point, even the concept of humanity may lose meaning. No languages. No nations. No records of who we were. Just a probe moving through the galaxy, containing a summary of life on a planet no one remembers. The golden record may outlive its creators by billions of years. Not because it's sacred. Because it's durable. In the far future, long after the sun expands into a red giant and consumes the Earth, Voyager will still be out there. A fragment of a dead world. Drifting. Unread. Voyager is no longer a mission. It's a monument. One that no one will visit. We build monuments to be seen. Pyramids. Statues. Tombs. Voyager is different. Its significance exists even if no one ever finds it. Even if no one ever listens. Even if its message is never decoded. Because Voyager answers a question we rarely admit we're asking. What do we leave behind when we know we won't be there to explain ourselves? Somewhere between the stars, a machine keeps going. It doesn't know we're gone. It doesn't know it was ever sent. It just continues. A small, artificial object drifting through an indifferent cosmos. Proof that once, briefly, a species chose curiosity over permanence, meaning over survival, and sent a piece of itself into the dark. Not to conquer it, but to say, "We were here, and we dared to look." The universe doesn't respond. It never does.